Hi, I'm Anton. I run a little website with MINDSTORMS hacks. So in this video I'm going to show you two hacks that I did. One with the Huskylens and one with the OpenMV. Both are artificial intelligence cameras, or cameras with onboard image recognition. And in this video I want to compare them both because they're quite similarly priced, and they're both built to be connected to robotic platforms. So let's first start with the Huskylens here. The Huskylens is a very new, neat little camera. Let's power it on. It's got a display on the back here, where and a little user interface with a button that you can press left, right, and down, and a teach button over there. Everything is packaged in this rubber cover. You can take it off, and then if you take it off, on the inside you'll find an SD card slot. I have connected this to a Spike Prime robot here. I've written a Python library myself to do this. I found a Python library online, but it didn't work quite well, and also it wasn't very efficient, so I started from scratch with my library. So it's fast and efficient and it works. And then I connected the Huskylens here to the Spike Prime using this breakout board of mine. I could have also soldered a wire, but I wasn't sure which wires went where. So then it's nice to have this breakout board so you can experiment a bit until you find the correct wires. And on this particular setup, I also have added a power bank to add extra juice to the Huskylens over its USB port here. The problem is that with the newer firmware on the Huskylens, it browns out from time to time. And if you downgrade it to firmware 0.4.7, you don't need the power bank anymore, but then you miss out on all of the SD card options, and there are also options to draw text on the screen from the Spike, and these commands aren't available in the older firmware, but you get rid of the power bank. I chose for the power bank option here. In the description below I'll link to the pinout here and the exact setup for connecting the wires. What I like about the Huskylens is the screen. Compared to the OpenMV, the screen is larger and it's got more pixels. What I also like about the Huskylens is how easily you can teach it to recognize lines or colors or objects. I found that with the OpenMV camera, this one is more powerful and you can do more with it, but it takes way more time to teach it to recognize whatever you want. This camera here recognizes stuff with just a change of algorithm and a touch of the button, so that saves a lot of tweaking and tuning and coding on the camera side. On the Spike side, it's pretty much the same. You just connect over UART, which is some kind of serial port, to the camera. Same here, and much like I've written a library to connect to this camera, I also written a generic UART library to connect to cameras like these. And once you've installed the library here on the Spike hub and on the OpenMV camera, communication is just a breeze. They just send over coordinates. So all in all, I think I'm pretty impressed here with the Huskylens. It's a beautiful package. It's quite compact. So compared to the fatter setup here on the OpenMV camera, however, here I've slid my breakout board is built for the OpenMV, so it's all compact on one wire. And it's easy to program. The speed is comparable, at least for image processing. So it's I think a reasonable choice for beginners. Now if you look at the robot performance of the Huskylens, you can see it's pretty accurate. Here I have
put the Huskylens into line recognition mode, so I taught it to recognize a blue ribbon as a line, and it's trying to follow that line. This is something that's pretty hard to do with a color sensor, because the ribbon is whoops, it got stuck behind the ribbon, but because the ribbon is not flat, it's very hard to recognize that. With a color sensor it is possible, but this works better. And here you can see that the Huskylens is confused with the intersecting lines, so to say, so I have to help it a bit. And yeah, the programming was fairly easy. I actually didn't use the complete line. I just look at the top of the line. So the Huskylens renders a little arrow over every line it recognizes, and I'm just looking at the head of that arrow. If it's more towards the left of the screen, I make the robot turn left. If it's more toward the right of the screen, I make the robot turn right. So I'm not really using the direction of the arrow here in the program. What I really liked about the performance of the line recognition is that it is fairly independent of lighting conditions. For instance, when on this section of the track, right after this corner, you can see that there is a lot of reflecting light on the ribbon, so it turns almost white. And here on this section of the track, there is a lot of shadow on the ribbon, and it turns very dark. And still the Huskylens manages to recognize the ribbon as a line, which is quite impressive. So all in all, this is a pretty useful camera if you want to expand your robot with vision capabilities. You can see here that I have used a power bank, because the internal power supply is just not powerful enough here to power the camera right from the 3-volt output.
To connect Huskylens to LEGO, I've used two M3 screws. I think they were 10 millimeters long, and these screws with two nuts here on the other side, they are spaced just right for 3 modules, and so this 7 module beam is about the size of the camera, and it works very nice to connect it to all kind of constructions. Then on this side there is the breakout board that I'm selling. You can of course solder it, solder your own, but using this breakout board you can connect to a Spike Prime robot, but also a MINDSTORMS EV3 robot with the Huskylens without soldering, so just snapping wires. I have the red and black wire here, of course, in ground and 3 volts, and then RX and TX are the blue and the green. They are down here in the corner, so the blue is all the way in the corner and the green is right next to it. With this setup you have RX, TX plugged right into your MINDSTORMS or Spike Prime hub. Let me remove the cover here for a bit. Can't remove it completely because of the beam in the way, but you get an idea what's underneath. Here there is an SD card slot. I wanted to put in an SD card to save my learned objects and save screenshots. And here you see a bit of the inside of the Huskylens. But if you're not changing SD cards, just keep it on, because the lens or the camera seems well protected like this. And it also looks a lot better with the rubber bit on. Now let's change the robot and change it over to an OpenMV robot. While I'm setting this up, also remember to subscribe to my YouTube channel. I really like it if you subscribe, because I'm hoping to reach 10,000 subscribers one day. Okay, with the OpenMV camera mounted, the whole setup looks a lot cleaner, because the The breakout board here is attached right on top of the OpenMV camera. There is just a single wire running to the hub, and no extra power bank needed. So this one runs very stable off the 3 volts that's coming out of the hub here. On the back there is a display. So hi there to the display. So this display is an add-on. It doesn't turn on by default, so you have to run code inside of the OpenMV camera that specifically initializes the display and sends images to it. But once you've done that, the display is a very nice addition here. And yeah, it works fine. A bit more, like I said, a bit more tweaking, a bit more coding, but then a way more powerful setup than the Huskylens, because of course, because you are programming the display yourself, you have full access to every pixel you are showing there, while with the Huskylens you're limited to the Huskylens firmware. Also with the OpenMV camera you can compile and download your own networks, your own image detection networks. So this ultimately is a way more powerful device, while this one is a easier device to start playing with images and robots. With the OpenMV camera, I think it took me about 2-3 hours to get it working, and with the Huskylens I was done in about an hour or something. So this one was faster, but ultimately this one was performing better, and I was able to tweak it more and make it go faster. So I think basically the choice, when you have to choose, between easy and powerful. To connect the OpenMV camera to LEGO, I've used 2 M2.5 screws with M2.5 nuts here on the other side. They fit about a 5-lung module, so I used this doggy bone here. The idea behind the doggy bone is that I can then build constructions in every direction. With this build, you can then slide on the display on the back. Okay, there goes the display, and it covers the nuts, the bolts here on the back. And then of course you can, the nice thing about this camera is that you can stack it, and then this breakout board that I made, I specifically, there is my logo, I specifically designed it to work with the OpenMV camera originally, and then I thought it was very handy as a general breakout board. So you just slide it on like that, in such a way that there is room for an EV3 wire to leave there on top, and then you're set up. So just mount this on your robot. Let's mount it here on this robot. Add another beam like that, and plug it in. There we go. The OpenMV cam is fully set up with a display, a breakout board, and it plugs in straight to the hub. The performance of the OpenMV camera on the robot is quite good. I used a slightly different algorithm on the OpenMV camera than on the Huskylens. This algorithm here is a color recognition algorithm, so it tries to find an elongated blob of blue color on the display, and where the Huskylens performed under very different lighting conditions, I had more trouble here finding the blue blob when the ribbon was very shiny. I also did an optimization here on the driving algorithm, and what it does is if it finds a very long blob that it is elongated, so it runs vertical on the screen, it cranks up the speed, so then it's safe to drive faster. And if the blob is short,
It slows down because probably there is a curve coming up, or I don't know, maybe the image isn't very clear, so slowing down is a good idea to get a clear image before speeding up again.
The OpenMV IDE user interface is rather daunting with a lot of buttons and text, but the cool thing is that you can see live video streaming in over USB and test all your algorithms here over USB while you tweak the Python code on the left here. So the code can become a little lengthy, but the cool thing is that there are a lot of examples included. I like, for instance, the feature detection, where you can find edges, circles, key point, or color tracking, where you can do blob detection with different colors. And there is it's really well documented, a lot of examples, an active community. So that's very nice, that's very powerful. Some things that I don't like about the IDE is that there is no auto indent. So every regular IDE after a semicolon here would put the cursor tabbed in, so I can start typing here, but this IDE does nothing like that. So you have to be very careful and make the indentations with Python yourself. And it's got some other quirks. For instance, what I don't like, if you comment things, that it doesn't comment, add a space here. So I prefer comments like this, but otherwise this IDE works reasonably well, especially if you have multi-file projects. It debugs, it shows you where the problem is. So if I would add a statement here, blah blah blah, blah blah blah, this would fail, and then when you run it, it highlights the error here, and you can easily debug it. What's also very nice is that when you're done coding, you can save the script to the OpenMV camera, and then whenever you boot the camera, your script is loaded. So it runs your script by default, and you can power your robot on and off, and it will always boot into your script here. So and then for instance, what I found really handy, oh, it will fail again, let me delete this dummy line. So what I found really handy here in the IDE is that for instance, for detecting the blue ribbon, I needed some thresholds. So you can select a range of blue here, and then you can see within that square what the lightness is, the A value and the B value, and you can use these ranges to find and detect and select the blue color here. I think right now the algorithm detects has some thresholds on basic orange, so it detects the orange pants here of Mr. Smarty Pants. Okay, now let's go over to the user interface of the Huskylens. Okay, this is the Huskylens user interface, and right now I'm in color recognition mode, so I can teach it to recognize the blue really easy with a touch of a button here. So it's learning the blue, and I can move the cross over all the hues that I want to learn, and then once I'm done, I can click the button again to learn another color. So let's teach it the red here of the minifigure's torso. So now I have two colors taught to the Huskylens, which is nice. I can also, oops, go back to color recognition. I can go into the menu here by long pressing, and also export my learned colors to the SD card in a slot, so I can load them later, which is a feature of the new firmware, by the way. In the old firmware you don't find this. And then what's a bit annoying is once you've done teaching it, you cannot unlearn one of the colors. So if I press this button again, it will forget everything, and I have to start over or reload it from the SD card. So learning the blue color again, I think I did something wrong. Let's forget it and teach it the blue color. Okay, there we go. So in a way, this is much quicker than the OpenMV camera. No programming involved. I can just teach, experiment, learn and relearn. What's also nice, by the way, about this camera is that it has a longer focal range. So right here the minifigure is pretty much in focus, and right there it stays in focus. So it either autofocuses, I'm not sure, I couldn't find that in the specs, or it has a very long focal range. And the disadvantage of the OpenMV is that you have to manually focus it. It doesn't have such a long focal range. So let's do another trick here and do object classification. So I can teach it the difference between a minifig. So let's teach it a minifig, and then not a ribbon. Whoops, I was too slow. So let's do that again. This is a minifig, and this is a ribbon, and this is a piece of table. Now we're done, and now we're in the object classification. So this is a minifig. It finds that. It's the first thing I taught it. This is the ribbon. It's the second thing, and this is the third thing. It's the table. So the classification is pretty accurate. It discerns between a minifig, a ribbon, and a table. I'm not sure what happens if I put another minifig on the table. Yeah, it also identifies that as a minifig. Let's see if it recognizes Marge from The Simpsons. Yes, it finds that a minifig, ribbon, minifig, table. So the classification is pretty neat. Do we have more interesting minifigs? Let's take this one. Yes, it's a minifig. It's a ribbon. It's a minifig. It's a minifig. So it's a lot of minifigs. It still registers as a minifig, ID1. And right now all that's left is a table. So the object classification is powerful and a lot of fun too. Now what else did I find interesting? Object recognition, I'm not sure. Yes, this is not really accurate, but okay, sometimes it recognizes the minifigs as persons, but sometimes they turn into bottles, birds, or airplanes. So yeah, I don't know what the ribbon is apparently a bottle. Does it find that this is a pickaxe? No, it's a bird. So there's only, I think, about 20 objects that it can recognize by default, but still, okay. No, the ribbon turns into a cat sometimes, or a bottle. These are the objects that I have handy. Yeah, it's a fun feature of the camera. I'm not sure I will use it a lot in practice because it's kind of unreliable. So that's the Huskylens user interface for you. There is a lot of power behind these buttons, and but then you're also limited to whatever the buttons can do. Okay, thanks for watching. I hope you enjoyed this video. I hope you, if you were considering one of these cameras, this video makes it easier for you to choose which one to buy. Remember to subscribe to this channel if you liked it. I'll make many more hacks and many more buying guides. And there is lots of links to code and examples and more explanations in the description below. See you in the next video. Bye bye.